looking back at when you studied limits, it's when we're analyzing problems where we're figuring out what the y value is headed toward given a certain x value. So the limit as x approaches 2 of x minus 2 over x squared minus 4 means if I plug in 2, I want to figure out where we're going to. But if I plug in 2, I get 0 over 0. In the second limit, it says the limit as x approaches infinity. So that would mean we'd plug in infinity, which gives me negative infinity over infinity, which doesn't make sense. Now, we learned some tricks on simplifying the fraction in pre-cal, and that helped when we had 0 over 0. But infinity over infinity, we need to figure out what to do. So, we'll have a conflict whenever something like that happens. There are several cases. If we have 0 plus or minus infinity, well, you're still getting infinity over infinity. Or it could be that you get 0. I'm sorry, that's 0 times. Infinity minus infinity. Well, is it 0 or not? 1 to infinity. Well, 1 to any number is supposed to be 1, but if you take any number to the infinite power, you get infinity. All of these cases are those that we're just not sure what the answer should be. So we've already studied some ways to handle this, like x minus 2 over x squared minus 4. If I factor the denominator, I get x minus 2 over x minus 2 times x plus 2. The x minus 2's will divide out. If I divide it from the numerator, I have 1 left. And x plus 2 is remaining in the denominator. Now, if I substitute in 2, I get 1 over 4. So that is the point, or the y value, that this function is approaching when x is 2. Now, it doesn't actually get there because there's a hole in the graph, but this is the value that the graph approaches. There was also a trick when we had the infinity going to infinity. That was actually looking at horizontal asymptotes, which in layman's terms, if I look at the largest leading terms in both of them, these are the only ones that are going to matter when we head to infinity. And what happens if I took negative 5x squared divided by 3x squared? Well, I just get negative 5/3. But these don't work when we have something like this. I can't factor because cosine x, that's never going to cancel out. This isn't going to work either because they're not going to divide out. So there's another technique, and it's called L'Hopital's rule. It allows us to evaluate limits when we have these indeterminate forms. If we have the limit as x approaches some value of f of x over g of x gives me 0 over 0 or infinity over infinity, then the limit is actually equal to the limit of the derivative of f and over the derivative of g. Let's try it out. On number 1, 3x squared minus 7x plus 2 over x minus 2. Well, if I plug in 2, I get 0 over 0. So what we can do is take the limit as x approaches 2 of the derivative of the numerator divided by the derivative of the denominator. 6x minus 7 over 1. Now if I plug in 2, 12 minus 7 is 5. What about number 2? If I plug in negative 3, I get 0. 9 minus 5 is 4. Square root of that is 2. Minus 2 is 0. Again, I would get 0 over 0. And it does help to show that that'd be 0 over 0 before you actually apply L'Hopital's rule. So if I wanted to find the derivative, the numerator and the denominator, let's think about what the derivative of that denominator would be. X squared minus 5 to the 1/2 minus 2. Get 1/2. X squared minus 5 to the negative 1/2 times 2x. I just wanted to come off to the side and do that one. Limit as x approaches negative 3. Well, the limit of the numerator is just 1. The denominator would be, let's see, 1/2 of 2 is x, of 2x is x. And then I have x squared minus 5 to the negative 1/2. Now, to the negative 1/2 means I can move it up to the numerator. 1/2 power is the square root. So square root of x squared minus 5 over x. When I plug in negative 3, 9 minus 5 is 4. Square root of that is 2 over negative 3. Negative 2/3. What about this one? Oh, goodness, this is crazy. If I plug in directly, I'll go ahead and tell you we're going to get 0 over 0. So let's take the derivative of the numerator and denominator. So 3x squared plus 2x minus 8 over 3x squared plus 16x plus 20. Now I'm going to plug in negative 2. So I'm going to come over to my calculator and plug in negative 2 into the numerator and in the denominator. This one works out really weird. It comes out 0 over 0 again. So guess what? We can use L'Hopital's rule again. So 6x plus 2 over 6x plus 16. Let's try it again. Negative 2, that's negative 12, plus 2 is negative 10, liking it already. Negative 12 plus 16 is 4. That's negative 5/2. It worked. Number 4, if I plug in 1, get 5 minus 4 minus 1, get 0 over 0. So let's use L'Hopital's rule. 20x to the 3rd minus 8x over negative 1 minus 27x squared. Plug in 1, get 20 minus 8 is 12. That'd be negative 28. That one worked. That would be negative 3/7. Comes in extra handy when we have cosines or e's. I wouldn't even want to try to simplify this. But if I plugged in 1, cosine of 1 is 1. 1 squared is 1. I get 0 over 0. So let's do it again. But let's take the derivative of the numerator and the derivative of the denominator. The derivative of cosine is negative sine. This would be 2x minus 1. What happens when I plug in 1? Well, the sine of 1 Back up a second. As I was working out this problem, I realized there's a typo. This should have been actually going to 0 for that to have happened. Cosine of 1 is not 1. Cosine of 0 is 1. And then 0 minus 0 would be 0. This does give me 0 over 0. I apologize, there was a typo on that problem. Let's try this again. Negative sine x over 2x minus 1. If I plug in 0, sine of 0 is 0. 0 minus 1 is negative 1. 0 divided by a number is okay. That gives me 0 as an answer. Let me change colors so we can see the separation on these two problems. Next one, let me make sure there's no typos. Looks good. Okay. If I plug in 1, natural log of 1 is 0 minus 1 plus 1 over e to the 1 minus e times 1. I get 0 over 0. Perfect candidate for L'Hopital's rule. The derivative of natural log x is 1 over x. The derivative of negative x is negative 1. The derivative of e to the x is e to the x minus e. Let's plug in 1. 1 over 1 minus 1. E to the 1 minus, we get 0 over 0 again. So let's do L'Hopital's rule again. 1 over x would be x to the negative 1. So I get negative x to the negative 2, which would be 1 over x squared. The derivative of negative 1 is 0. Derivative of e to the x is e to the x. Now let's plug in 1. 1 squared is 1, so I get negative 1 over e to the x. That, e to the 1, sorry, I forgot to plug in that. That is an okay answer. Limit as x approaches 0, I would get 0 plus 1 minus 1 over 0. Indeterminate form. L'Hopital's rule. The derivative of the numerator. Be careful here. We're going to have a product rule. So 2x sine x plus x squared cosine x minus sine x over 2x minus 2. What happens if I plug in 0? 0, 0, 0 over negative 2. That is okay. Next one is one of the infinity ones. Now we could use the trick, but I'm going to show that we can also use L'Hopital's rule. Derivative of the numerator is negative 4 minus 10x over 6x minus 1. If you plug in infinity, you get infinity over infinity. Unknown. Try again. Derivative of the numerator is negative 10. Derivative of the denominator is 6. We get negative 5/3. Beautiful. Let's go for number 9. If I plug in infinity, get infinity over infinity. Bad answer. So let's use L'Hopital's rule. Derivative of the numerator is going to be 8x minus 5 over e to the 5x times 5 plus 1 over x. Again, I get infinity over infinity. Yuck. Try again. 8 over 25 e to the 5x minus 1 over x squared. And when you plug infinity in, you're going to get infinity in the denominator. Now anything divided, so 8 divided by infinity approaches 0. Nice. So that's how you use L'Hopital's rule.